So you just got done simplifying rational expressions, and now we're ready to multiply rational expressions, and I think you're going to see that there's really not a whole lot of difference between the two. So here's an example of our first multiplying rational expressions. Basically, anything from the top, whether it's on this side or this side, can cancel out with anything on the bottom. So you can cancel out from here to here, or you can go diagonally and cancel something from the top here with something from the bottom over here. You can't cancel out two things that are both on top or two things that are both on bottom, but you can cancel any one thing from the top with that same thing on the bottom. So there's a lot of different ways to do this. I like to start with just the numbers. So I have 2, 3, 8, and 5, or 15. So 2 goes into 2 one time, and it goes into 8 4 times. And then with 3 and the 15, 3 goes into 3 one time, it goes into 15 5 times. Now you could multiply all of this together and get one rational expression and simplify from there, but you don't need to. I have x to the fourth and x squared on top. On the bottom I have x squared and x to the third. I'm going to take this x squared and cancel it out with this x squared. I still have 4 x's on top and 3 x's on bottom, so I'm going to get rid of all 3 x's on the bottom. To do that I have to get rid of 3 out of these 4, so that just leaves me with 1 x. And then for my y's, I have 2 on bottom, so I'm going to get rid of both of them, but I have to get rid of 2 out of the 5, so that's going to leave me with 3 left. So I have a 1 and a 5 on top, so 1 times 5 is 5. I also have an x and a y to the third. On the bottom, the only thing that I have left is 1 and a 4, so 1 times 4 is 4. So here's my simplified rational expression when I multiply these two together. I still need to do the domain restrictions. Remember, that's anywhere where x, or in this case x and y, are not allowed to be 0. Even though everything's canceled out at the bottom, we don't want to look for it here. We want to look for it at the beginning. So we did have x's and y's in the denominator at the beginning. So that means that x is not allowed to be 0, and y is also not allowed to be 0. If you have a problem that looks more like this, your first step is to factor everything that you can possibly factor. So I can't do anything with this one or this one. They're already factored as far as they can go. On this one, I can factor out of 3, and that would leave me with x plus 4. So this one has now been factored. This one, x squared minus 4, is going to factor into x plus 2 and x minus 2. So now our domain restrictions are going to come from this step. It's any factor in the denominator. So we're going to have 3 of them. X cannot be negative 4, negative 2, or positive 2. Remember, it's what x cannot be equal to. So take your factor, set it equal to 0, and solve. So if I have x minus 2 equals 0, I would add 2. That means x cannot be 2. If it was 2 minus 2, then I would have 0. So now I can cancel anything with the top from anything with the bottom. So this is a factor x plus 2. So I can cancel the x plus 2 out with an x plus 2 from the bottom. I have the factor of x plus 4 that I can cancel out with the x plus 4. Now when you cancel everything out of the top, it does not mean it's 0. If you cancel everything out, there was still a 1 x plus 2. So there's still a 1 on top. So my answer is going to be 1 over, on the bottom I have a 3 and an x minus 2. I'm not going to distribute them. I'm going to leave the denominator completely factored. I still need to do my domain restrictions. So we said that we were going to have 3 of them. So x cannot be negative 4. Right here it can't be negative 2, and here it can't be positive 2. So I'm just going to give a list of what x is not allowed to be. So this entire thing is my final answer. This is what I get when I multiply these two together in its simplified form. Here are all of the numbers that x is not allowed to equal. Remember, if I were to put any of these numbers into my original, I would end up with a 0 in the denominator of one of these, and I can't divide by 0. So that's why I have this list of domain restrictions. So now for this last one, I want you to pause it and try it yourself, and then check and see if you got the right answer. So go ahead and pause it now. Alright, so your first step was to factor everything that factors. So if I factor out a 10, I would have gotten 10 and then x minus 4. This one doesn't factor. This one is going to factor into x minus 4 times x minus 2. And then this one I can factor out a 5, and that would leave me with x plus 3. So I've gotten rid of all of these. I've replaced them all by factoring them. Now I can go through and factor or cancel out any of my factors from the top and the bottom. So I have an x minus 4 on the bottom and on the top. I have an x plus 3 that I can cancel out. I also have a 5 and a 10. 5 goes into 5 one time. It goes into 10 two times. So the only thing that I have left on the top is a 2. And then on the bottom, I have 1 times x minus 2. I cannot cancel these out. This 2 is attached to an x minus 2. If it's helpful for you, you can leave them in parentheses, but once you have a factor by itself, you no longer need the parentheses. So this is 2 divided by x minus 2 is my final answer, and I still need to state my domain restrictions. So what is it that x is not allowed to be equal to? So right here, x cannot be positive 4. Right here, x cannot be 2. Here, there is no variable, so I don't have any restrictions in my domain here. And then on this last one, x cannot be negative 3. So this is my final answer. You should be able to go ahead and do the homework on the right now.